Mathematical practice number 4, model with mathematics. Modeling with mathematics is more than just drawing a picture. As we model with mathematics, we identify the mathematical element, we create mathematical models, and we talk about the relationship with those. There's lots of different ways that we can do this, and the thing that I like about this is that as we talk about, oh, they need to know the standard algorithm. No, they don't. What they need to know is they need to know how to model it with mathematics. Now, the standard algorithm for long division is a type of model. It is not the only way we can do it. It is a type of model. And we need to understand that it's an additional model. So how do we use it? We model mathematic ideas and problems in a variety of ways. We draw a picture, we make a diagram, we do the bar model, we do the standard algorithm, we do the area model. There's lots of different models that we can do to break things down. Some are pictorial and some are numerical. Either way is okay, but we do need to help them understand how to model that. Now, we don't have to show them every type of model. Hopefully, they can start creating some, and they might be ones that are already out there, but they're their own. They're not contrived from the teacher. They're not saying, you have to do it this way. There's lots of different ways they can do it. The purpose behind it is not so much that they have to draw it, because teachers will say, well, it'll take them too long. That's okay. The idea behind this is that as they see a problem, they can visually represent, they can visually understand what's happening. And so they can model these types of things. They need to be able to analyze the models to draw conclusions and solve problems. What is happening in this model? How is this model related to this model? How are these intertwined? As we talk about long division, you can go from a concrete drawing it model and take them to the next step of using numbers, and taking them to the next step of breaking it down by place value, and then the next step of what's considered the standard algorithm. Those are okay, and they can show those. And do they need to be at the end of using the standard algorithm? No, they don't need to, but you can show them how to do that. One thought that I've had over time is that we started with very concrete things, and great scientific or mathematical minds breaking things up into different chunks and showing how to do that. And then hundreds of years later, somebody came along and said, oh, here's a formula to do that. And then hundreds of years later, somebody came up with a more efficient way to do that. And hundreds of years later, somebody came up with the most efficient way, or so far what we teach in math class. And we want our students to go from their very simplistic minds and jump hundreds of years that many great mathematicians have come to shrink down. I understand that we can get them there, but why are we pushing them so fast when it took hundreds of years in order for mathematicians who are way smarter than me to come up with these models that we use now? So some type of models we can use is, there's the bar model and the part-whole model and the math mountains, and there's the base 10 blocks. There's drawing models, there's the standard algorithm, there's the area model, there's the place value model. There are so many, and some of them have multiple different names, but there's lots of different ways that you can do these. One thing that I want you to think about, creating models challenges our students to delve into their understanding of math ideas in order to represent them. One other thing that I want you to think about is, as we use these models, we have multiple entry points for our students, because there's multiple different ways to think about things. There's multiple different ways to analyze what's going on so that our students can understand and represent what is going on in their mind. And so use models. This also ties into number 3, where we have to construct a viable argument. Why does your model work? Does your model work? And as we have the model, we as teachers will be able to delve into the minds of our students to see what they're thinking. rather than what's considered the standard algorithm where we just have to see if they know how to calculate problems right.